Hi, good afternoon. Welcome to our third lecture. The topic of today's lecture is MVC and Java Servlets, which is going to allow us then to use Java Servlets in a structured way to provide an architecture for our internet applications. The idea of a software architecture is that it provides for us an abstraction of a software system. An abstraction is really just stripping out the details to look at the high-level information, to allow us to focus on the major components without being distracted by the low-level detail. So with a view of only the high-level components, we can then see the structure much more easily. And when we devise some kind of abstraction for our software architecture, it means that we're then able to take that abstraction and implement it in different ways. So what I'm going to say in a few minutes about MVC will be applicable to any kind of software that uses that architecture. Although we'll be looking at it in the context of Java Servlets, you could use these same principles in a Java program, a C program, and any other kind of programming language that you want to make use of. Now, why do we want to use an abstraction? Well, the first thing that it does is to reduce complexity. As I said a few moments ago, it strips away the low-level detail and allows us to focus on what's important at the time. The other thing that it does is aim to reduce complexity by separating concerns. And the idea of a concern is really tied up in terms of responsibility and function. Who is responsible for doing something? And when they do it, what do they actually do? What's the process? What's the function that they perform? And we apply that concept to our applications by focusing on responsibility and function and identifying those components that deal with a particular area of functionality. And we try not to allow any crossover of responsibility and function. And so as we define the individual component types, we identify their concerns in terms of function, the properties that they need in order to perform that function, the relationships between the various component types, and the way in which they interact. Why do we want to do this? Well, there are several advantages of having an architecture. The first thing is that it allows us to standardize our designs. When we have a web application that we want to develop, if we've already got in mind that we're going to use, let's say, MVC, then we immediately understand the basic structure of that internet application. And therefore, we can view our interactions with the user in a certain way. And those interactions will have a certain structure. And therefore, we're able to very quickly identify the bits and the pieces, the components that we shall need for this particular application. Another advantage is that we have a shared understanding. Shared with whom? Well, with other developers. We might be working as part of a large team in developing a very large internet application. And if we've got a common understanding of what the system design should be, because we're all using the same architecture, then that helps in communication. It helps in development. It helps in debugging. It helps in the ongoing maintenance. It also helps in terms of the longer term, because it's not just at development that we have lots of people involved. There will, over the course of perhaps many years, be lots of people involved in maintenance and change of the system. Because the architecture presumably has been tried and tested over time, and indeed with MVC that is the case, it's been used in all kinds of places for a very long time, it means that we have an enhanced quality of our design and implementation. And if it's got an enhanced quality, that means it's going to be a better system. And as I've mentioned a few moments ago, it improves maintenance because we're able, as soon as we know that we're using MVC as the architecture, we can very quickly find our way around the system. And improved extensibility simply means that we can add additional features in without too much problem. Because the architecture, as you will see in a few minutes, the architecture lends itself to adding in components. Some of the disadvantages though, well, the fact that you're using this level of abstraction means that you've got to think about things a little bit more before you start doing it. It's not just a case of diving in and writing some code. We have to start planning a little bit before we write the code. So we're going to have to think carefully about how to match what we are using for the implementation to the architectural components. And what we're going to have to think about first of all is how we match servlets to the MVC components. There's a design overhead. As I said, you've got to think about it, but you've also got to plan it. And having made your plan, you then implement according to that plan. Well, this design, therefore, will take time, and that's an overhead. But that is offset by improvements in quality, productivity, maintainability. You can improve your productivity quite a lot simply by doing the plan first, because that's where you do all the creative thinking. All the hard decisions are made, really, during the design. Then, having done that on paper, or electronically, it doesn't really matter, but having done it up front, you've thought about all those difficult problems, and you've come up with solutions. So that when it comes to implementing, your productivity at code time is enhanced considerably. Not only that, but when you come to use this architecture at implementation time, you're going to build the components and have those components interact in a predefined way, because the architecture defines what those components are and how they interact, how they communicate, and so on. So all of that is set out for you in the architecture, and therefore you don't have to spend time thinking about that at implementation time. One of the other disadvantages of an architecture is that it can introduce a lack of flexibility. You might want to do a little tricky thing in a very special kind of way, and maybe the architecture doesn't lend itself very easily to that. And so you'll have to think about whether you ought to do it in that little tricky, clever way, or whether you ought to stick to some kind of standard architecture. Very often, although you might have to do that little tricky, clever thing in a slightly different way to make it fit the standard, and therefore it isn't quite as tricky and clever as it would have been otherwise, that loss of cleverness, perhaps, is certainly offset by the usefulness of standardization and this shared common understanding of how things work. The trouble with introducing tricky, clever things, of course, is that you might be the only person in the whole wide world that really understands how it works. And if you're no longer around for whatever reason to maintain that tricky, clever thing, then of course, then that's going to cause really big problems for whoever has to come along behind you to clear up the mess. So let's talk a bit about MVC, Model View Controller. The separation of concerns here is that we have a model component that will deal with the data in the system, a view component that deals with how that data is presented, and a controller component whose job it is to basically organize things. So the model will deal with the data and the related business rules for updating and retrieving that data. And that is separate from the view, whose job it is to present that data to the user. And both of these are separate from the controller that manages the user interaction. So there we have the separation of concerns. We've got responsibility defined. Model is responsible for data and the related business rules. View is responsible for presentation. Controller is responsible for management. So they've got their individual responsibilities, quite distinct, no overlap, and there is some communication between them. So for a given user interaction, the controller should normally activate one or more model components and then activate one or more view components. So we're starting to see then that there's some interaction because the controller is going to be activating these. And so we could have a configuration that might look like this. Step number 1, there'll be some input from the user that comes into the controller. The controller decides what kind of input that is and will then, in some way or another, activate a model component. In this particular example, the activation consists of an update. That model will then do what it does with the data according to the business rules, and then the controller will cause the view to be refreshed. And as part of that, the view will need to read that data. And the view's final job is to output to the user the results of that interaction. Let's consider separation of concerns a bit further. We have the global separation. Model is separate from view, both are separate from controller. But at the lower level, there's still this separation of concerns. Let's consider, for example, only the model components. Each individual model should perform one functional operation, and that's it. So instead of having a component that will update and retrieve customer details, we should use two separate components. Both of them are model components. One will be responsible for updating customer details. The other will be responsible for retrieving customer details. Those are two functional, those two components are functionally separate. They might be operating upon the same data, but one of them will be updating, the other retrieving, so they're quite separate. The advantage of doing that, of course, means that having separated them, we now have a component that is reusable. The retrieve customer details component could be used in all kinds of different places without having to be coupled to the update first. And we can do a similar thing with separation of view components. So here we have another example. The update customer request comes in to the controller, whose first job will be then to activate the update customer model component, who will write to the database. Then the controller will activate the retrieve customer component. This is a model component that will then extract from the database that information that has just been written to it. Then the controller can cause the customer view to refresh, that will get the information that has been retrieved here and then output it. Another example, request 1 comes in. The controller will activate the model and then the view that relates to that request. Then a different request comes in to the same controller, and this time, having distinguished that it's a request type 2, it will activate a different set of model components and view components. So we can see here then that we could have, in this particular example, a controller that interacts with the user, receives all the requests that come in, and will then activate a different set of model and view components depending upon which request has been received. There are all kinds of ways in which we could configure this. We might, for example, decide to have a single controller for each interaction. But for now, I think we'll probably stick with this last configuration. So having identified the architecture that we're going to use and discussed its principles and the way the components interact with each other, now we've got to think about how to take that abstraction and apply it to our implementation. With our internet applications that are written solely with Java servlets, then the model, view and controller components are all going to be servlets. Because the controller has to be able to activate model components and view components, then we have to work out how one servlet that will act as the controller can then invoke model components and view components. And with servlets, there are three ways of doing this. We can use the include mechanism, the forward mechanism, or the redirect mechanism. To include a servlet, we need, first of all, to declare a request dispatcher object. Create the object by calling from the request parameter that comes in on as a parameter to the doPost or doGet method. From that object we call getRequestDispatcher. And we pass to it a string which is the URL of the servlet that we want to activate. This method will then return a dispatcher object that is set up to target that URL. And then we can, from the dispatcher object, call the include method and pass the request and response objects that we are currently dealing with. And so what we can see here is that this servlet, which is, let's say, the controller servlet, which has received a request object and a response object from the servlet container, will then pass those exact same request and response objects to the next servlet. So the next servlet will be operating on exactly the same request and exactly the same response objects as the original controller servlet. If we want to forward to a servlet, then it's very similar. In fact, the only thing that's different is instead of calling dispatcher.include, we call dispatcher.forward. So what's the difference? Well, it's all to do with the flow of execution. When we include another servlet, then we're going to halt execution of the invoking servlet and switch control over, execution control, to the invoked servlet. When that has finished executing, control then comes back to the invoking servlet. And then the invoking servlet will continue its execution from the point where it left off. Whereas with forward, execution does not come back to the invoking servlet. And so forward would essentially be the last thing that servlet does. The redirect, which I haven't got a slide for, but the redirect is a completely different mechanism, because what happens is the servlet that receives the request will then issue via the response object a redirect command that goes back to the web browser, and then the web browser will issue another request for the nominated servlet to which it has been told to redirect. So in the first two examples with include and forward, when the web browser sends its request, it has no concept whatsoever about the include and the forward that might have taken place. As far as the web browser is concerned, it sent in a request to the controller servlet and it got its response from the controller servlet. all the internal workings of the forwards and the includes are completely transparent to the web browser. It knows nothing of them at all. On the other hand, with the redirect, the web browser sends the request, the controller then sends back a message to say redirect to this other servlet, and then the web browser sends a second request, but this time to the other servlet. So it's a completely different mechanism. Now what I'm going to show you for the rest of the lecture is an example of taking a servlet that has been written with all the model view and control in one servlet, and then we're going to split that up into individual servlets so that the components are properly separated. So let's start off by looking at the HTML. Here is the form. The action that we're going to put in here, of course, is the URL for the servlet that we want to activate. We're doing a get method here, and we're passing in a taxi num and a taxi location as data that's been entered in a text box by the user. And then there's the submit button here. This URL, no MVC separation, will be used by the servlet container. It will, of course, consult the web.xml file and will find the URL pattern no MVC separation, which gives it the servlet name MVC start, and then the servlet tag, which has the same servlet name, will identify that the class that we're using is servlets.mvcstart, which is this class here. So here's the servlet with everything all bundled up into one servlet, exactly as we've been writing since the beginning of the module. So what we have then is the setting up of the output stream, and then within a try block we're going to get from the request those two parameters, the user supplied data, taxi num and location, and store those as strings in these variables here. Then we're going to output some header information for the HTML file, all fairly standard stuff. Then we have to think about the data that we've got. And here we've got a business rule. The business rule states that taxi num and location must both have some data in them. And if they are, then what we're going to do is to process that data simply by echoing it back straight to the web browser. So it's not a very sophisticated manipulation of data, but that's not the point. We're wanting to focus on other things. Else, well, else means that one or both of the items of data were empty. And so we then must output a message and detect if the taxi num is empty, output a message to say the taxi num is missing, and then if the location is empty, output a message to say the location is missing. If they're both empty, because we're not using an else if, and that's quite important, because they're both empty, we want both messages to appear. And so by having a sequence of ifs, if one is missing, and then if the other is missing, we'll get both messages. Let's concentrate on, or use as an example, some really quite absurd example. What if we had 100 data items that the user had to type in? And let's assume that the user has typed in absolutely nothing and clicked the submit button. That means that there would be 100 messages potentially. If we had written the code in this way, then the very first one that was missing would set that condition to be true, and that message would be output, and because of the else, all the other 99 messages would not be output. Just a single message. Now you think, that might be quite a useful thing to do. Don't want to overload the user. But the problem is, that's one message. So the user thinks, oh, all right, and goes and corrects the problem and clicks submit. And now, that message, or that condition rather, is false. So we then come on to here, and that one becomes true. So the message is output. And then you've got another 98, else if, and so on. And they get skipped over because of the else if. And so only one message goes back to the user, and the user thinks, oh, okay, I'll correct that one, and click submit. Do you really think that the user will get to message number 100 with the 100th correction? I don't think so. And therefore, to help our users as much as possible, we output as many diagnosis messages as we can, so that they can get the full picture as quickly as possible and understand, okay, they might be overloaded with 100 messages in the first instance, but at least they know what's gone wrong. So let's make, with our validation here and our reporting, let's make these ifs a sequence of ifs rather than one big if-else-if statement. Finally, after all that, we need to output essentially the trailing HTML tags, end of body, and so on. Once all that's been done, we're using a finally block to make sure that the output stream back to the web browser has been closed. Now let's think about what we've got here. That's all one servlet, but let's think about the responsibilities and the components that are embodied in here. We have, to begin with, a little bit of model, get the data. And then, further down here, we've got process the data, but only if, and therefore we've got some control. So we've got some decision making taking place. We've also got here some output information. So that's view. So we've got model, view, control, model, a bit more control. This lot is all about view, what messages to send back, and then more view. So it's all jumbled up into one program. And that's not desirable. If we wanted to, we could stick with a single servlet, but then we would want to separate all the model and view and control into individual methods within that one servlet. But you can't have a very big system and do it all in one servlet, so we might as well look at how to do it in several servlets. So let's do that. In the project, let's look at the control first. In the controller, what we want to do is to take from this monolith all the bits of control. So mostly all of that is model or view. The bit that's control is this bit. So we want that if statement in there. We also want to separate out the model stuff into a model component, a model servlet. So we shall want to invoke that servlet. Now, for us to be able to make the decision here, we are going to have to involve that bit of model processing in the controller. So we're going to have to do that. So over in the controller then, actually, sorry, I didn't quite plan ahead well enough. This is a slightly better approach than what I was about to tell you. So let's go with this one that's in the example. In the try block, what we simply do is invoke the MVC model servlet. So remember, what we put in here in the request dispatcher is the URL of that servlet, and then dispatch using an include. Then, assuming that everything works, the model servlet will return, and then we're going to invoke the MVC view servlet. So, which servlets are they? We need to go back to the web.xml file and find the MVC model pattern. So we're looking for the URL MVC model. There it is. And the name for that is the MVC example model, which, if we come back up to the servlet tags, the MVC example model is that one with the class MVC example model. So if we find that class, MVC example model.java, here is our servlet that is the model component of this interaction. So it gets that information there. The business rule is that they must both have a value, and therefore our implementation of that business rule is to check. If they don't have values, if just one of them is missing a value, then we're going to throw this servlet exception. So we're creating a new instance of the servlet exception, and we're putting in, sorry, let's move that, we're putting in a message. That is the end of processing. So if there was no problem, that is, both data items have got values, therefore the business rule has been satisfied. In a more complicated environment, we would then go on and process that. But in this very simple example, the process is, well, I've checked it, there are no problems, now let's return. On the other hand, if there is a problem, it's going to come back by throwing an exception. So back in the controller, we're going to invoke that with an include, and one of two things will happen. Either there will be no problem, and therefore control returns to this line and will then continue with invoking the view, or this will start, the servlet will be executed, the model servlet, an exception will be thrown because there's a problem, which means the try block aborts, and we then start looking through the catch blocks to see if there's a handler. Well, it was a servlet exception that was thrown, and therefore this block will catch it. And all we're going to do from here is to get that error message, and if it is equal to the phrase input error, then what we're going to do is to invoke the error view instead. Because if we come back to the original monolith, we can see that there were two kinds of views. There was the normal process and the view for I've got some errors. So in the controller then, we will invoke the model. If there's no problem, we will invoke the normal view of the data. Otherwise, if there is a problem, we will invoke the error view. So let's have a look at those two views. The normal view is going to have the output stuff that was in here. So if we come up there was all that output stuff that is now in the view for the normal data. And then we've got the bit of the view that processes the data and presents it in the way that we want it, and then we've got the end. If we then look at the error view, we'll find that the same stuff for the header is here, so it's been duplicated now. So we might have a bit of a problem there. It might offend our sensibilities about you should only write stuff once if you can. Come back to that in a moment. We've also got the duplication of the trailer, and in the middle of that we've got the processing of the invalid data. So we've now got two separate views, and that's all controlled by the controller. Invoke the model, and then depending upon the response, invoke the normal view or invoke the error view. Now what about these two views that have got duplicated code? Well, we now can see that it's very easy for one servlet to invoke another. So if we've got a servlet here, two servlets that have got exactly the same bit of code, then extract that, put it into we might call it a header servlet. And then we can invoke the header servlet from each one of the views. And likewise with the trailing bit, we might call that a trailer servlet, and invoke that one from each one of the view servlets. So being able to invoke servlets like this is actually a really useful thing to be able to do, because we can separate the concerns, we can compartmentalize the common bits, put them in a servlet, and then invoke those whenever we need them. And that essentially is MVC in an internet application. So your work during the tutorial this week will be to design interactions, or will involve interactions that essentially look like that. And this is what we've just done. We had a request come in, there was one controller, it invoked one model, but then it had a choice of views. So there were two views that could have come from here, one or the other. Now, as you go on into this module, you'll be developing applications that have got multiple requests going into a single controller. Each controller will, the controller for each request will then invoke one or more model components, one or more view components. And so you're going to have to plan that. And these kinds of diagrams, which are essentially an invention for this module, it will be good for you to write diagrams similar to that. So we're calling those component diagrams. And so when you're asked in the tutorials to write component diagrams, well, use something like this. Okay, so that is the end of the lecture for today.